Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in this video we are going to study about the flow rate measuring device known as Venturi meter. Here we will study its construction, principle of working, and then we will see its working with the help of a diagram. After that we will study its advantages, disadvantages along with its applications. So let us start with our topic. Venturi meter, it is a device which is used for measuring the flow rate of the liquids flowing in a pipe. So Venturi meter, it is a type of flow rate measuring device, and this Venturi meter, it is also known as an obstruction meter, or we can say that it is a type of obstruction. It is called an obstruction meter because when this device is placed in the pipe in which the fluid is flowing, whose flow rate we want to measure, so in that pipe, this Venturi meter, it acts as an obstruction or as an obstacle. So because it is acting as an obstruction or as an obstacle, it is called an obstruction meter. Now, when this Venturi meter, it is placed in the pipe, it is acting as an obstruction, and due to that presence of the Venturi meter, the change in the pressure occurs. So due to obstruction, there is a change in the pressure in the fluid. So suppose that in the pipe the Venturi meter is placed. So the pressure of the fluid which is flowing before the Venturi meter and the pressure of the fluid flowing after the Venturi meter, there will be a pressure difference at those positions. So if we are going to measure the pressure difference before and after the obstruction, this pressure difference is proportional to the flow rate of the fluid. We are going to use a pressure sensing device and this differential pressure measuring device, and this device is going to measure the difference in the pressure at these two positions, and with the help of that we will be able to find out the flow rate of the liquid. So we can see here that in the Venturi meter, because it is acting as an obstacle or as a restriction in the path of the fluid, so it is called an obstruction meter or restriction meter. And due to this obstruction, there is a change in the pressure of the fluid, and by measuring this pressure difference, we can measure the flow rate of the fluid. So with the help of this Venturi meter, we are not directly measuring the fluid rate, but we are indirectly measuring it by measuring the pressure difference. So we can say that the Venturi meter, it is using, or Venturi tubes, they are using a indirect method for the measurement of flow rate. And they are the mechanical means of measurement. Mechanical means that this Venturi meters, they are acting as primary sensing elements for the measurement of the flow rate. Okay, and the construction of this Venturi tube is like this, that it is acting as an obstacle in that. Okay, so it is having an indirect method and a mechanical means of measurement of the flow rate. So this was just an introduction about the Venturi meters or the Venturi tubes. Now let us see the construction or the main parts of the Venturi. There are three main parts of Venturi meter. First is a short converging part. The middle part is called the throat, and in the last we are having the diverging part. So the Venturi tube or Venturi meter is divided into three parts. First is the short converging part, middle one is called the throat, and last is the diverging part. Let's see the diagram of the Venturi meter. So this is the diagram of the Venturi meter. You can see that it is having three parts. The short converging part, that is the inlet cone. In the middle it is having the throat, and in the last it is having the outlet cone, that is the diverging part. Now converging part, it is that part of the Venturi meter where the fluid gets converges. Okay, the fluid is flowing in a uniform cross section. After that, due to the conversion of this converging part of this Venturi meter, the fluid also gets converges. Okay, now the inclined angle of this converging part is 15 to 20 degrees. And its inclined angle is 15 to 20 degrees. Okay, next is the throat. Throat is that part which lies between the converging and the diverging parts, and it is having very small cross section, smaller than the converging and the diverging parts of the Venturi tube. So the throat is the middle portion which lies between the converging and diverging part, and having the smaller cross section or less cross section than the converging and the diverging parts. Now when the fluid enters this throat, because it is having very small cross section, so due to that the velocity of the fluid increases, and as the velocity increases the pressure decreases. So you can see that the principle of working of the Venturi meter, that the Venturi meter, it causes the change in the pressure of the fluid, so that is being caused due to the throat portion of the Venturi tube, because it is having very small cross section. So due to small cross section, velocity is going to increase and pressure is going to decrease. So a pressure difference is being created by the Venturi tube. This is the portion of the Venturi meter where the fluid diverges. First the fluid converges, enters into throat, and after that it diverges. So this was the construction of the Venturi tube. Now comes the principle of Venturi tubes. We have seen that its working depends upon creating the pressure difference. So how it measures the flow rate by measuring the pressure difference? Let's see. Now the working of the Venturi tube, it is based on the Bernoulli's equation. The Bernoulli's equation gives us a relationship between the pressures, and it says that for an ideal fluid, an incompressible fluid, okay, so for that the total energy at any point of the fluid is constant. Okay, so working of the Venturi meter is based on the Bernoulli's equation, and this equation states that in a steady ideal flow, of an incompressible fluid, the fluid which cannot be compressed, because if we are using a compressible fluid, so when it passes through the converging and the diverging parts, it will be compressed. Okay, its volume will be reduced. So we are using an incompressible fluid, and in a steady ideal flow the total energy at any point at any point of the fluid is constant. Okay, now this total energy, it consists of three parts. It consists of pressure energy plus the kinetic energy plus the potential energy. Potential energy, or we can say the static energy, means at rest position. So pressure energy plus the kinetic energy plus the potential energy, it is constant. Okay, so this is what the Bernoulli's equation says. Now if we mathematically represent it, then mathematically pressure energy is equal to P upon rho into G. Kinetic energy is V square upon 2G, and potential energy is Z, and it is equal to a constant. Okay, now here all the energies, they are taken as per unit weight of the fluid, so it is a volumetric energy. Okay, now as in this Venturi tube, if we apply this Bernoulli's equation, so Bernoulli's equation says that at any point of the fluid, this energy is constant, the total energy is constant. So if we are measuring the total energy at this converging part and at the diverging part, means at section 1 and at section 2, if we are measuring these total energy, so they will be equal, because the total energy is constant at any point. So if this is section 1 and this is section 2, so before entering the throat and after leaving this throat, if we measure the total energy, that will be constant. So same equation, if we apply it for section 1, it will be P1 upon rho G plus V1 square upon 2G plus Z1 equals to P2 upon rho G plus V2 square upon 2G plus Z2. Okay, because both are constant. Now rho is the density of the liquid, G is the acceleration due to gravity, P1 is the pressure in the section 1, P2 is the pressure in the section 2, V1 is the velocity in the converging part, V2 is the velocity in the diverging part, and Z1 and Z2 are the potential energies. So this is the principle of the Venturi tube, that if we measure the total energies in the converging and the diverging part, the energies are constant. So we will use this equation to derive the velocity or to find out the fluid flow rate. Now in this equation, if we see the pipe is horizontal, so if the pipe is horizontal, then Z1 is equals to Z2. So this equation is reduced to P1 upon rho G plus V1 square upon 2G equals to P2 upon rho G plus V2 square upon 2G. Now if we take pressure terms on one side and velocity terms on the other side, it will be P1 minus P2 upon rho G equals to V2 square minus V1 square upon 2G. Now this term P1 minus P2 upon rho G, it is the difference of pressure heads in section 1 and section 2. You can see that it is the pressure difference. P1 is the pressure in the section 1 and P2 is the pressure in the section 2. Here we are having P1 and here we are having P2. So this is the difference in the pressure and it is equal to H. Okay. So H is equal to P1 minus P2 upon rho G. Now if we put the value of H in this equation, so H is equal to V2 square minus V1 square upon 2G. Now let's apply the continuity equation in the Venturi tube. The continuity equation says that A1 V1 is equals to A2 V2, where A1 and A2, these are the cross-sectional areas of the section 1 and 2 respectively. So A1 V1 is equals to A2 V2. Now from here the V1 is equals to A2 V2 upon V1. Sorry, A2 V2 upon A1. Now substituting this value of V1 in this equation, where we have get H equals to V2 square minus V1 square upon 2G. So H is equals to V2 square minus V1 square, that is A2 square V2 square upon A1 square divided by 2G. So from here, if we get the value of V2, so it will be 2GH equals to V2 square minus A2 square V2 square upon A1 square. Let's take the LCM on this side. So 2GH is equals to A1 square V2 square minus A2 square V2 square upon A1 square. Taking V2 square common, so V2 square is equals to 2GH A1 square upon A1 square minus A2 square. So from this, V2 is equals to A1 under root of 2GH upon under root of A1 square minus A2 square. So in this way we can find out the velocity of the fluid. V2 is the velocity. Now V2 we have obtained here. Now if we substitute the value of V2 in the equation, we know that discharge is equals to A2 V2, means flow rate is equals to A2 V2. So Q is equals to A2 is a constant and means cross-sectional area, and V2 we have already obtained its value. So putting its value, we will get A1 A2 upon under root of A1 square minus A2 square under root of 2GH. So this Q is the theoretical discharge under the ideal conditions. So we have used the Bernoulli's equation, and starting from the Bernoulli's equation we derive the term, or we derive the formula for the flow rate. Now this flow rate is under the ideal conditions. We have assumed earlier that it is the case of a steady and ideal flow for an incompressible fluid. Now if we find out the practical value of this discharge, then actual value is given by CD A1 A2 upon under root of A1 square minus A2 square under root of 2GH. where CD is the discharge coefficient of Venturi meter. So this is how, with the help of the Venturi meter, we are measuring the flow rate by measuring the pressure difference. We started with the Bernoulli's equation. Okay, and Bernoulli's equation says that this is constant. So in the Venturi meter, in the section 1 and section 2, the total energies will be equal. We neglected the potential energies Z1 and Z2. They are equal, so they will be cancelled because the pipe is horizontal. After that, using this equation, we find out the change in the pressure, that is P1 minus P2 we find out, and this is H, that is the difference in the pressure heads. Now after that we use the continuity equation. With the help of that we find out the value of V2, and after that we put the value of V2 in the discharge equation, and after that we find out the flow rate. So this is the derivation for the Venturi meter, that how flow rate is measured using the pressure difference. Also we can say that this is the principle of the Venturi meter. Now let's see that how the Venturi meter works. As we have seen its construction, that it is having the converging and the diverging part. So from here the fluid enters into it. There are two cross section, one is the inlet and other is the throat. Now at the inlet there is a high pressure tap. Okay, because at this position the pressure will be maximum and the velocity will be minimum. Because it is having a converging part, the area available is very more, so fluid will be having very less velocity but pressure will be more. So it is the high pressure tap. From here we can measure the pressure P1. When this fluid it passes through this throat, so at this throat, because it is a very small part, so velocity will be maximum but pressure will be minimum. So here we are having a low pressure tap. So from here we will measure the second pressure, that is P2. Okay, and after that we will do the derivation, and with the help of that equation we can measure the flow rate. So at the inlet we will be having maximum pressure, and at throat we will be having minimum pressure. So low pressure and high pressure taps are available to measure the P1 and the P2, and by calculating this pressure difference the rate of flow of the fluid can be measured. So this was the working of the Venturi meter. Now comes its advantages. The advantages of Venturi meter are that there are less chances of so these Venturi tubes, they are not going to get blocked due to the suspended materials present in the liquids. So clogging is not a problem in case of Venturi tubes. Coefficient of discharge is very high. So the behavior of the Venturi tube can be predicted perfectly. They can be installed either vertically, horizontally, or in the inclined positions. They are more accurate and can be used for a wide range of flows. And through the Venturi tubes, around 90% of the pressure drop can be recovered. And they can be used for measuring very high flow rates for large pipes. They have very well-known characteristics. So these are some of the advantages of the Venturi tubes. Now comes its disadvantages. The disadvantage of Venturi tube are that they are very large in size. So hence their space is limited and they cannot be used in those conditions where the space is very limited to us. They are expensive, means their initial cost is very high. And their installation and maintenance is difficult. Also, they require low line length. Long laying length because first they before the Venturi meter it requires a straight pipe, and after that first the converging and throat and the diverging part, so its length is very much, so it requires a long laying length for it, and that is why it cannot be used in pipes which are below 7.5 centimeter in diameter. As I've already said, their maintenance is not easy and they cannot be altered pressure beyond a maximum velocity. So these are some of the disadvantages of the Venturi meters. If we talk about the various types of Venturi meter, then they come in different shapes like long form, short form, eccentric and rectangular type of Venturi tubes. So here in this video we studied about the flow rate measuring device Venturi meter, which is a type of obstruction meter. Here we studied its construction, its principle, we derived the equation for the flow rate measurement, we saw its working with the help of the diagram, and we studied its applications along with its advantages and disadvantages. So I hope that this topic is now clear to you. Thank you.